Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the 8th question from the mid-year examination, which was written in the province of Eastern Cape in the year of 2024. Please do note that guys, there will be a total number of 9 videos since the question paper has 9 questions in total. That means each and every question will have its own video. And please guys, do take this seriously, because I strongly believe that knowing how to write, or rather tackle exam questions, will give you an edge whenever you write your examination. I know that right now you might be preparing for your mid-year exam, but please do use these videos to prepare for your preliminary exam as well, and as well as your final examination. I believe that guys, this will give you an edge, né? So please do share the video to your peers so that they may have the same edge as you. And please do help us grow the channel guys by just subscribing. Okay. An observer walks at a constant velocity towards a stationary sound source that emits sound at a frequency of 2450 Hz. The frequency detected by the observer as she approaches the sound source is 2500 Hz. Okay. On the statement, guys, I already know that the source emits a frequency of 2450 Hz, and then the detected frequency is 2500 Hz. I also know that the source is stationary, so the speed of the source is 0 meters per second, but I do not know the speed at which the observer walks at. Okay, they want us to state the Doppler effect in words. Né? Doppler effect simply states that it's an apparent change in the observed frequency of the source as a result of relative motion between the source and the observer. Doppler effect is the apparent change in the observed frequency of the source as a result of relative motion between the source and the observer. Okay, then now they want us to explain in terms of wave motion why the detected frequency is higher than the frequency emitted. Okay, this is true guys, because whenever the observer moves towards the stationary source, the wavelength the wavelength of our sound source will definitely decrease, and at a lower wavelength, that means frequency will increase. Why is that the case? Because frequency is inversely proportional to wavelength. So if our wavelength decreases, that means the frequency detected will be higher. Okay. Then now they want us to calculate the speed of the observer as it approaches the sound source. Take the speed of sound in air as 340. Okay, we have already established that the frequency of the source is 2450 Hz. The frequency detected is just 2500 Hz. The speed of the speed of the source, since the source was stationary, that's just 0 meters per second. We are looking for the speed of the listener, and the speed of sound in air, we are told to take 340 meters per second. Now, the Doppler effect equation simply says FL is equal to V plus or minus VL all over V plus or minus Vs times the frequency of the source. Now, okay, the first thing I've noticed there is that my source rather is stationary. So that means at the denominator I'll have V plus or minus 0. Basically I'll be left with V. Are you together? But now remember that guys, at the top I have V and VL. I must choose plus or minus over there. Are you together? I must choose plus or minus over there. So since guys the listener is moving towards the source, at the top you should always have a plus. Whenever there's towards movement, at the top you should always have a plus. Né? and then at the bottom it should always be a minus, and it's obviously vice versa if there is away movement. If guys, in this scenario the listener was moving away from the stationary source, I was going to write a minus over there. Okay, now let's just substitute and then calculate the velocity of the listener. I have 2500 is equal to 340 plus VL all over 340, and this is still multiplied by 2450. Okay, whenever I divide both sides by 2450 like this, or let me say I'm multiplying by 1 over 2450, I'll end up having 50 over 49 on the left hand side being equal to 340 plus VL all over 340. These will just cancel, né? Okay, and then all I have to do now is to just multiply both sides by 340. I'll simply have 340 multiplied by 50 all over 49 is equal to 340 plus the velocity of the listener, and hence the velocity of the listener is basically 340 times 50 all over 49 minus 340. 340 times 50 all over 49 minus 340. This will simply give me the speed of 6.94 meters per second. So the lady was just walking towards the stationary source at a speed of 6.94 meters per second. That's just 6.94 meters per second. Okay, how will the wavelength of the sound wave emitted by the source change in the following scenarios? Ne? Write down only increase, decrease, or stay the same. When the observer stands next to the sound source, guys, whether the observer stands next to the sound source or the observer moves away or towards the sound source, the sound wave emitted by the source will just remain the same. Stay the same. Are you together? Okay, when the observer moves away, the sound source will just stay the same. Are you together? The only thing that would change the sound waves is if the siren starts emitting sound at a different pitch. Are you together? So since they are not changing the pitch of the sound source, whether the listener is moving towards, moving away, or standing next to the sound source, the sound will still emit the same frequency. Okay, the observer decides to run towards the direction of the sound source at a higher constant speed than the speed calculated in 8.3. How will this affect the following? Write down only increase, decrease, or stay the same. The detected frequency, this will increase. Remember that, guys, FL is equal to V plus VL all over V multiplied by Fs. Ne? If this guy over here increases, that means the frequency detected will be increased, will increase as well. Ne? Okay, the speed of sound, guys, will never change. It will only change if ever the environment is changed. Are you together? If it's still in the same environment, the speed of sound does not change. This will just stay the same. Okay, the emitted frequency from the sound source. The emitted frequency from the sound source, it doesn't matter, guys, whether the observer is running is backpedaling whatever the observer is doing. The frequency emitted by the sound source will only be changed if ever the pitch of the sound source is changed. Are you together? So this will simply stay the same as well. Okay, give two applications of Doppler effect in the medical field. They're using it for a sonogram. They also use it to check the pulse if ever a person is still alive, and to check heartbeat as well. Are you together? So those are the three I've given you. I know that there are more. Are you together? But they wanted two, and I've given you three. Nah? Yeah. So that's how, guys, you were supposed to tackle this question over there. So just stay tuned and wait for more videos. Dank.